Hi everyone. So we're going to finish this short series of one-to-one functions and implied domains by talking about implied domains and their significance and importance in relation to one-to-one functions. Okay, so you might remember, I don't know, a while back we talked about an implied domain meaning the largest possible domain for which your equation makes any sense, right? So that's what our definition, our working definition is going to be here. So the implied domain of a function is the largest possible domain for which the rule makes sense. And it's the domain that we assume when none is specified, when none is given to us. All right? So look at these examples here. Look at these functions. These are polynomial functions. So we've got f of x equals x. Now it doesn't matter what value of x you put in there, you'll be able to get a corresponding y value. Okay, you'd just be the same thing. So the domain for that is all real numbers. Same for x squared, same for x cubed. No matter what x value you put into that function, you'll be able to get an answer. Okay, even though the domain is not specified, okay, we say that the implied domain is all real numbers. Okay, and then later on we can restrict it if we want to, just like we did in the previous video where we had to restrict the domain to turn our parabola into a one-to-one function. Okay, and that's the significance of the implied domain. You kind of have to know what your implied domain is to begin with before you can write a restricted domain when you're turning something into a one-to-one function. Especially in the case of like parabolas and stuff that have been split down the middle, or things like hyperbola, stuff like that. Okay, you sort of need to know what the implied domain is to begin with. All right. For things like square roots, okay, you've always got to think, well, what values of x make this thing make any sense? Okay, what makes a square root able to be evaluated? Well, the only condition that you need to have in place is that the thing inside the square root, which we call a radicand, that number is not allowed to be negative. It has to be 0 or greater. Okay, so that is the condition that you need to place on yourself when you're trying to figure out the implied domains of square root functions. Similarly, I haven't written it down on the slide, but things like hyperbola and truncus, all right, you'd be doing things over x or something over x squared, something over a denominator which has x inside it. Okay, so we'll see an example of that in a second, but basically that denominator is not allowed to be 0, and therefore there are only certain values of x which you will be allowed to put in to avoid getting a denominator of 0. Okay, so let's have a look at some of these examples and trying to work out the implied domains of each of them. So first we've got function f of x equals the square root of 2x minus 5. Now what condition do we have to place on ourselves so that we can evaluate the square root? Well, we just have to make it so that the thing inside the square root, this 2x minus 5, is greater than or equal to 0. If it doesn't satisfy this condition, then that value of x is not allowed to be in the domain. Okay, so what is the domain? Well, we're simply just solving this inequality now. So we can get 2x is greater than or equal to 5, and x is greater than or equal to 5 on 2. So no matter if x is greater than or equal to 5 on 2, you can put that into here and you can safely find a corresponding y value. Okay, you can evaluate that function. If x is less than 5 on 2, you're going to run into trouble because you'll end up getting a negative inside the square root. Okay, and so you say that the maximal domain or the implied domain for this function is all numbers x greater than 5 on 2, or greater than or equal to 5 on 2. Okay, if you prefer interval notation, you could write it as 5 on 2, comma, infinity. Okay. All right. What else we got? So this is a form of a hyperbola. So we've got 1 over x plus 3. Now notice, depending on the value of x, there's a certain value that will make your denominator 0. All right, can you think of what that value would be? If you can't see it straight away, well, let's make the denominator 0 by doing x plus 3 equals 0, and then solving for x to figure out what value of x would make it 0. Okay? So if I just solve this little equation, I get x equals negative 3. Okay, so if I put x equals negative 3 into here, I'll get 1 over 0. That's not allowed. Okay, but any other value of x will work just fine. So our domain is all real numbers except for negative 3. Okay, that's how you would write the implied domain for that function. Finally, we have another square root looking thing. And again, you just ask yourself, well, what values of x will make it so that this square root is able to be evaluated? Okay, so we have the condition that 9 minus x squared must be greater than or equal to 0. Otherwise, if it's not, you get a negative inside. Okay, so let's rearrange this. We can write it as x squared is greater than or equal to 9. Sorry, apologies, less than or equal to 9. Okay, so let's first of all think what number squared would be equal to 9. Can you think of a number squared that would be equal to 9? Well, that's just the number 3. Or is there another number as well? Yes, negative 3 squared will also give you 9. Okay? Now, if the value of x is anywhere between those two values, 3 and negative 3, then when you square that number, it will definitely be less than 9, wouldn't it? Okay? If x is outside that range of numbers, so let's say x is 3.2, if you square that, you get a number larger than 9, which is not allowed. Or if x is, say, negative 3.2, if you square that, you get a number that's larger than 9, which is not allowed based on the inequality that we've set up here. So the allowable x values for this particular function are in between negative 3 and 3, inclusive. All right. Now, you might be wondering, well, how the hell did we get this? Like, you might just be confused. What did I do here? Okay, let's recap quickly. We have to make it so that the square root is able to be evaluated. And it's only able to be evaluated or worked out if it's greater than or equal to 0. Okay, we can't do square roots of negative numbers. So this thing inside must be greater than or equal to 0. Which means x squared, bringing it to the other side here, x squared is less than or equal to 9. And the values of x that when you square it give you something less than or equal to 9 are the numbers between negative 3 and 3. Okay? If you prefer, you can go back and figure out how to solve quadratic inequalities. One of the ways that we can solve it is to draw a graph of it. Okay, so 9 minus x squared is the inverted parabola that has a y-intercept of 9. Okay, and you can also work out the x-intercepts of this parabola. They're going to be negative 3 and 3. This inequality symbol is asking you, where is this parabola, 9 minus x squared, greater than or equal to 0? It's greater than or equal to 0 on this interval here, between negative 3 and positive 3. Our graph is above 0. It's greater than 0. Okay? At negative 3 and 3, our graph is equal to 0, meaning that it's on the x-axis. Okay? So that interval there, between negative 3 and 3, including negative 3 and 3, that's where we get that answer from. Okay? In fact, this here is the equation for a circle that has a center, I believe, of 0, negative 2, and a radius of 3. Okay, or rather the top half of a circle. Anyway, that's our implied domains. Okay, an implied domain is the largest possible domain for which your equation, your rule, makes any sense. Sometimes certain values of x will make it so that you can't work anything out. So you have to disregard those values and only include values that do make sense. Okay, so we'll stop there. That's it for this short series. I'll see you next time.